So over here we have a wooden block, right? And the gravitational force acting on the wooden block that is shown by the downward blue arrow is shown as 19.6 newtons, right? So what do you think will happen if we drop this wooden block in the tank of water? Okay, very good. So what's the level that you see right now of the liquid? Exactly, 100 liters. And now if we drop this block in the water, obviously it will rise up, but then whatever liquid it will have displaced to take its place inside the tank will be collected in the container over here. So do you see? So it says fluid displaced, exactly. So the amount of liquid that will be displaced by the block when we drop it will be collected in this container over here, okay? And we can then see the weight of this fluid by looking at the newtons, the number of newtons that shows up over here. So what I would like you to see is what happens when we drop this and what value do you see of the weight of the liquid that shows up in the container, okay? Let's have a look. Okay, so what's the value do you see of the weight of the liquid that has been displaced, so fluid displaced? Yes, exactly. And what's the value of the upthrust shown by the pink arrow? So the upward force. Exactly, very good. So what do you think is the relationship between the upthrust and the weight of the liquid that was displaced? Exactly, they have the same value, right? So the amount of upthrust that the block is experiencing, which is 19.6, is equal to the weight of the liquid that it has displaced. Okay, so how much liquid it has moved out of its way to make space for itself within the fluid. So weight of that liquid is equal to how much upthrust it's experiencing. Okay, is that okay? Brilliant. The reason why there is this upthrust force is because the pressure difference that you have when you are submerging this object in the fluid. So if you look at the container itself, and if we look at the levels at which the top of the box is or the bottom of the box is, which one is deeper? Is the bottom of the box deeper in the container or the top of the box? Yes, so the bottom of the container is much lower inside the container. So the pressure over there is much greater than what you have at the top of the box. So because of this difference in pressure level, there you got the bottom of the container experiencing a lot more force than compared to the top of the container. And this what the pressure difference causes the upthrust force. Okay, so then let's check our understanding. What do you think is the volume of the sphere that is submerged? Make sure you're looking at the scale. Perfect, very good. So how do you know? Exactly, that's it. So it is 5 ml because we can see that the after the ball has been submerged, the level of the liquid, it was previously 10 milliliters, now it is 15 milliliters. So that's why we know the difference in which and the level has risen by is 5 milliliters. So the volume of the object itself is equal to the volume of the liquid it has displaced, right? So that's why we have volume of the sphere 5 milliliters as well. What do you think is the value of the upthrust in this scenario? It says value of the upthrust force. Excellent, that's it. So we know that the upthrust is equal to the weight of the water. Okay, so how do you know the weight of the water? Good. So we have the mass, we can calculate the weight, right? So we know weight is mass times G. So mass is given to us, which is 2 kilograms times G, the value of G is 9.8. Then we can calculate the weight of the liquid displaced, and this is equal to the force, upthrust force.